Welcome back. This is Algebra 2, Unit 4, Section 6.2, Polynomials and Linear Factors. This is video 1 of many. I'm going to go through some vocab to start for this section, and the goal is really to get comfortable with factors and what they look like as zeros and interpreting those in both directions as well. If we were given zeros, we'd be able to write them as factors. Okay, so first couple terms, you should all feel very comfortable with these terms right here: solutions, zeros, x-intercepts, and roots, because they all mean exactly the same thing. They're all values that create zeros for a polynomial, not just a quadratic function, but any polynomial with any degree. That's what the zeros, that's what the roots are, that's what the x-intercepts are, that's what the solutions are. So let's explore again when we had factors, when we were using zero product property to solve for quadratic functions. We produced factors that looked something like this. They were binomials and they were linear. And when we used those factors to create zeros, we set both of these factors equal to 0 and we solved for the variables. So if these were our factors, these as zeros look like x equals 7 and x equals -2. In observations, you should be able to see, notice how a -7 inside of a factor actually turns into a +7 as a 0. Or a +2 inside of a factor turns to -2 as a 0. So if we did this in the opposite direction, if we were given zeros first, if I told you that 3 and -5 were zeros, you should be able to recognize that as a factor that should look like x minus 3, and -5 as a factor would look like x plus 5. So as a factor compared to as a 0, they kind of look like opposites of each other. Very important fact and a topic to understand. Okay, more vocab. We have relative maximum. That is a maximum point between two zeros. A relative minimum would be the same idea, but a minimum point between two zeros. So minimum point between two zeros. And a multiple zero is said to have what's called multiplicity. That means it occurs more than once. So here's what all of these look like on a graph. So on a graph, let's say I'm graphing a cubic function, so it looks something like this. It would actually start out looking like a parabola, and then it would turn twice. So here are my zeros. Here's one solution. Here's another solution. Here's another solution. So this point right up here would be considered a relative maximum. It's a high point on the graph between two zeros. It's not the highest point on the graph. Notice how this graph goes on forever. It continues. So it's not the highest point. It's not the maximum point for the graph, but it is between two zeros, as well as this point being a relative minimum, a minimum point between two zeros. And if I'm graphing something with multiplicity, multiplicity on a graph looks like a graph's going to approach an axis and touch it and then turn back away, but it actually approaches it and sort of continues on the same direction. So let's say I had the following graph. I got a lot of zeros, and here I'm approaching it. It looks like I'm going to hit this and turn back down, but I actually continue back upwards. A point that looks like that on a graph will have multiplicity. That means it will appear as a factor more than once. Okay, so we have a polynomial. It's written in factored form. What I want to do is identify what these zeros are. First item. So each factor leads you to a 0. Remember, if we're solving, we want outputs of 0. And since this is already in factored form, something times something times something times something else, that means all of those somethings could be equal to 0. That's what zero product property says. So x could be equal to 0. That's one possible 0. X plus 3 as a 0 would be -3. X plus 4 as a 0 would be -4. And again, I could set all these equal to 0 and I could solve for the zeros. I'd be getting the same value. The one that's interesting right here is this x minus 1, which really means x minus 1 as a factor twice, which really means that the 0 would be 1 and since it's a factor twice, it would be said to have a multiplicity of 2, because as a 0 it occurs 2 times. And I'm not going to take the time to do this last part, but we can talk about it, then write a polynomial in standard form. That just simply means that we would have to multiply all of these together. And we'd have to take the time to multiply 2 of the binomials together. Take that answer, distribute it to the next binomial. Take that answer, distribute it to the next binomial, which I don't want to take up that amount of your time. But we are going to do this on the quick check. So I have an expression. I have 3 binomial linear factors, x plus 1, x plus 1, and x plus 2. The goal is to write this as a polynomial in standard form. So when we multiply, we can multiply things in any order. That's commutative property. So I'm going to just start by multiplying the first 2 binomials together, which is just big distribution problem, which we should all be good at by now. So we should get x squared plus 1x would be 2x's, and then 1 times 1 is 1. So there's the product of the first 2 linear factors. Notice how it produces a cubic trinomial. That's pretty consistent. And then secondly, I have to multiply that cubic trinomial by the third factor, which now there's lots of distribution that has to happen. So I'm going to start by distributing the x squared to both parts. So x squared times x would be x to the third, and x squared times 2 would be a plus 2x squared. Next, I'm going to distribute the 2x to both parts, so that would be plus another 2x squared plus 4x. And then lastly, I'm going to distribute the 1 to both parts. So 1 times x would be a positive x, and 1 times 2 would be 2. And then lastly, we want this in standard form, so I'm going to combine my like terms. Here's 2 quadratic terms, so we'll combine those into 4x squared. Here's 2 linear terms, that'd be a total of 5x's with an addition of 2 and an x squared at the front. Or excuse me, an x to the third at the front. And then the last part, we have to name this thing, which really means classify. We have a degree of 3, which means we have a cubic function, and we have 4 terms, so we'd call that a polynomial with 4 terms.